Today we'll consider addition of vectors using parallelogram, followed by kinematics in one direction. Then we'll quickly look at displacement, followed by average speed. Of course, we'll consider average velocity. We'll look at when velocity is at instantaneous position with some examples which I will want you to try on your own. Alright, so let's get started. First is addition of vectors using parallelogram. Consider two vectors, vector A and vector B, at an angle theta to each other, as you can see in this first figure. If we construct lines parallel, okay, and equal to A, okay, and to B, or this is from A to B, you will obtain parallelogram with the resultant R as the diagonal. As you can see in figure B. Okay, so using the fact that sum of the co-interior angle equal to 180 degrees, so if you look at C, you can then have theta, or you have phi to be equals to 180 degrees, okay, minus theta. That's what you have. This is your phi. So your phi will be 180 degrees. Whatever this is, this will be equals to what? 180 degree minus what? Minus what this theta is. You have to take the degree. That's what gives you the phi. You remember your cosine rule? Okay. So that's where you put your cosine rule into use. Where you have a squared equals to b squared plus c squared minus 2bc equals a. And if you want to have d squared equals to a squared plus c squared minus 2ac equals b. And for c squared to be equals to a squared plus b squared, okay, minus 2ab equals c. So if you know the magnitude of a and b, and of course phi, then the r can be determined. R. This is how you determine R. R can then be determined as R squared to be equals to what? A squared plus B squared, okay, minus 2AB. What do you have? Cos 5. Okay, so that's what you have. Alright. Then maybe we should look at examples quickly, or you have to try this on your own. Suppose a car travels from point A in an easterly direction for 10 kilometers to point B, and then travels another 5 kilometers in a direction 60 degrees north of east to point C. You can now determine, okay, the total distance traveled and the displacement of the car using parallelogram method. Can I see your comment section? Okay, I want to see your trial comment section. I'll be glad to see you there. Okay, to take it again, as you can see, suppose a car travels from point A in an easterly direction for 10 kilometers to point B, and then travels another 5 kilometers in the direction 60 degrees north of east to point C. Okay, determine the total distance traveled and the displacement of the car, okay, using a parallelogram method. I love to see your trials. And the second perspective to look at today is kinematics in one direction. All right. So to set an object in motion, a force has to be exerted on it. Kinematics is the study of objects which are already in motion. That is, a force had already been exerted. Then the object is already in motion. For kinematics, we disregard the force that caused the motion in the first place. We don't look at that. When you begin to look at the force, you begin to see the dynamics. But for this class, we are concerned with kinematics, to the force that caused the motion of an object. Okay, so a study of the forces will be considered maybe subsequently. All right, we'll look at the dynamics. So to describe the motion of an object, all right, we need to specify the position of the object. We need to specify the position of the object in the first place, okay, with respect to some frame of reference and the reference point. A frame of reference, many of you will ask, what is a frame of reference? A frame of reference is a set of coordinate system used to measure the properties of an object's motion, such as displacement, velocity, acceleration, etc., etc. So a reference point is the point where we start measuring these properties. The Cartesian coordinate, this is a typical Cartesian coordinate as you can see. So the Cartesian coordinate system may be considered as a frame of reference. Okay, this may be considered as a frame of reference where its origin is a reference point. Look at here, this is the origin. Y and Z, maybe variably can take this as Z, but we're not concerned with that for now. As this are the directions the object may take. It may take X direction, Y direction, or it could be Z direction. Okay, if it's for instance, if you have a three diagonal, but in this case we're considering only one direction of kinematics. Okay, so since we consider the motion of object in one direction, that is one dimensional motion, okay, either it's going Y direction or either it's going X direction, that's what we consider. Okay, so the properties of an object that we will consider are displacement. That's what we'll consider in this one. Look at this car now. This car is traveling along this X direction. Okay, so we'll discuss the displacement of this car, okay, the speed, okay, along the X direction, and the velocity, and of course acceleration. All right, so, okay, in reference to this origin. Okay, so, but for now, since we've been doing that, let's quickly then look at the displacement. So displacement is the change in position of an object in a specified time interval. The displacement can also be understood as the distance from the initial position to the final position along the straight line. You can see if you have a straight line from initial position, that's point A, then going through to point B, which is the final position in this case. All right, of course, the straight line, okay, means displacement. All right, so consider two people, all right, traveling from point A to point B. Through part one, you can see this is the first part 1 and 2. So the person traveling through part 1 will travel a long distance than the person, okay, traveling through part 2. You can see this part 2 seems not to be a shortcut, of course. So however, their displacement is the same. Their displacement is the same, just that the time at which the person that passes through the first part got to point B is quite shorter. So the time the person that passes through part B here, go to point B, but overall they both have displacement. All right, so if we align the system, should we align that along the direction of the displacement? We can determine the magnitude of the displacement. All right, so the magnitude can be defined or can be obtained using this formulation. Okay, so in this case, this is of x, which is the direction of the displacement towards x direction. As you can see, the arrow that points to that. So what you have is equals to change in x. All right, change in x means the final, okay, position at x minus the initial position. Are you getting that? So your final position is xf or subscript f, and you have x subscript I, which is the initial position. We can take that again, right? So we have, there's displacement along x direction coming from A to B. So in this case, if you, for instance, should you have maybe let's say at point A you have 10, if it's 10 kilometer, so to the final position you have, let's say maybe 25 kilometer. You know what that means. So you have to take the final away from the initial position. Do you understand that? Average speed, all right? The average speed is what we shall be considering now. Still looking from kinematics in one dimension perspective. The speed of an object, of course, is a measure of how fast it is moving. Okay? The speed of an object is a measure of how fast it is moving. Average speed is the total distance. Because average speed is the total distance over elapsed time. The total distance traveled divided by the time taken, which is mathematically given as this. That's your average speed. Okay, so if an object covers the same distance after a given equal time, that object is said to be at uniform speed. If it is at equal given equal time, okay, that object is said to be at uniform speed. In this case, the graph of the distance. You can see here the graph of the distance. You can label this one as graph A. Okay, yield a straight line. Okay, so the distance is a function of time taken. All right, so we can also look at this non-uniform, as if the distance traveled after a given time keeps on increasing. If it keeps increasing after a given time, the object speed is said to be non-uniform. So the graph of distance traveled against elapsed time, you can take this one as B. Okay. The graph of distance traveled against elapsed time is a parabola. In this case, you can see it's a parabola. Okay. Coming from the perspective of average speed, the average velocity in a given direction is the total displacement. Is the total displacement in that direction divided by the total time taken. Of course, mathematically, you can write it this way. Change in t means t final minus what? The t initial. That is this will be the total time, and the bar indicates, of course, the bar here indicates what? Indicates it is an average. It is an average. Bar over the v indicates average velocity. Indicates that velocity is average velocity. All right, you will take note of that. So for a motion in a straight line along the x-axis, okay, if I show you the other time, so you can have the average velocity will be changing x, that is the final position, the object. You take the final position and then the initial position. All right, then you do justice to that using this formulation. For convenience, you can put it this way, and then we can now go to instantaneous velocity, right? Or you want me to take this again? So for a motion in a straight line along the x-axis, the only non-zero component in the x direction is what? Is Vx. So that you can just write this, for convenience. Just mathematically, you can express that for convenience. Okay, as V bar V equals to change in x over change in t, and of course you know what the group means. Okay. So, let's talk about instantaneous velocity. Instantaneous velocity is the velocity at any instant during the motion of an object. During the motion of an object. In order to obtain an estimate, okay, of an instantaneous velocity, what you need to do, you measure the displacement over a very small interval. In order to obtain an estimate of an instantaneous velocity, measure the displacement over a very small interval. As the time interval of our measurement gets smaller, okay, the average velocity will approach the instantaneous velocity. In what follows, okay, we will refer to instantaneous velocity simply as velocity, okay, in our subsequent courses. All right. So then let me show you some examples before we complete this segment. Okay. So you can look at this. I've earlier given you one. I also want to see this one through your comment section. You must talk to me from there. So if you understand this, okay, you can take. You can just take this for a home form. A jogger goes for her usual afternoon run. She leaves from her house and jogs around a round trip of 10 kilometers in 1 hour. What do you think is going to be our fix? Okay. So please let me see that through your comment section. I'll be glad to look at it. Okay, or you can take it again. A jogger goes for a usual afternoon run. She leaves from her house and jogs a round trip of 10 kilometers in 1 hour. What is our average speed and our average velocity after 1 hour? I want to see that in your comment section below. Okay, so let me look at this quickly. You can look at this one. Some example: cyclist rise at constant velocity and then stops for lunch. She rides back to the place from where she started at a different constant velocity. Okay? So you have to find the average velocity in each of the regions, A, B, and C, as indicated on the graph. Let me show you the graph quickly before we leave that point. You can see this is region A, B, and C, as I've mentioned here. So I want you to find the average velocity in each of the regions. That is, if this is a region A, this is region B, and of course this region C. I want you to find what? I want you to find the average velocity in each of these regions. Okay, so another thing I want you to do is to find the total distance traveled by the cyclist. What's the total distance from point A to C? I want to know. I also want to know if you can find the displacement covered by the cyclist. Okay, the displacement covered by the cyclist. I would like to see that. Just go through the comment section and try your best. Now I'll be there to see you. Okay, another thing you can do is to find the average speed for the whole journey of the cyclist. You should look at that. The next thing I think you should find is the average velocity for the whole journey. Find the average speed for the whole journey and find the average velocity for the journey. These are all simple tasks or home form that I want you to go through. And